as an open elective. So so let me check with the syllabus. So these are the outlines of the syllabus. So today I will give you some introductions of the subject with the different type of renewable energy resources and different potentials and some of the outlines. And we will discuss about the solar energy, we will discuss about the wind energy, biomass energy, we will discuss about the tidal wave, ocean, we will discuss about the hydropower or hydro, small hydro specifically, geothermal energy and hydrogen. And finally, we will give some, I will give some idea about the hybrid system. So utilization of different energy resources or renewable energy sources to have the hybrid system. So in a week we have the 3-hour lectures, but I will take only 1 hour. So this is continuous lectures. So more than 1 hour is really difficult. So I will take 2 hours lectures in a week, and so I'll try to cover up with that. So I'll share all my PPTs and study materials in the form of PDF. Okay, so don't worry about the study materials. And so I think so this subject has been catered with this both the campuses. I think so this subject will be delivered in the online mode only. So it is very difficult to gather this amount of student in a single classroom. I think so. Okay, so so this will be, I think, in the online mode for this semester. Let's check someone is knocking. And try to join by within the 5 minutes. Huh? So come with the background. So this is so this paper is the renewable energy resources. So we'll discuss about the energy resources, energy conversion, and its utilizations and its impact. So you know that people and other organisms use Earth's resources for their everyday living. So this is necessity. And people use energy resources, most of which originated from the sun. And you know that sun is the ultimate source of energy. So this so everything is not able, na? It is understandable voice. So are you there?
Yes, sir. Yes.
Okay. And often when you use the natural resources, that can impact the Earth's land, air, and water. And you know that, so there is a stringent and environmental norms, pollution. So people are there to catch you if you have some mismatch with the. So there will be a lot of impact. And you know that nowadays, so there is a, people are telling about the climate change, greenhouse gas emissions. So energy resources are there. So proper utilization is a prime concern for the most of the engineers, investors, as well as policymakers. Okay, so we'll learn this subject in such a way that so we'll learn the lot of energy resources and its utilization to generate the electricity. Basically, we are mostly interested about the electricity. That is a sophisticated form of the energy. And you know that most of the students are from electrical background, so we are trying to develop a lot of devices to have better and technology in the form of conversion, in the form of transmission, in the form of distribution, whatever the things. Okay, so this is the little background of the syllabus. So this is a burning areas. So most of the research, people are trying to develop the energy materials, smart materials. Okay, so demand, basically there is a huge demand, and not only that, electricity is as a product you cannot store in a large capacity. So always you can generate based on the demand only. Okay, so always, so there is a relation between the demand and supply. So why so important? So what I have told. So human activities are dependent on the uses of several forms and sources of energy, and so there is a and and there is a rise in demand. There is an increase in, and due to the economic development, so there is a rapid industrialization, globalizations. You know that. So and not only that, so due to the use of electronic components now, each and every people use the electronic components, and that means you are utilizing, or you are consuming the electricity. But unfortunately, so the total power consumption is about this huge capacity, and that is mostly comes from the fossil fuels. Say 80 to 5%, 80 to 85% that is coming from the fossil fuels. So those are going to replace. So basically, and those fossil fuels are in deeply living in nature. So those are non-renewable. So, so we'll discuss what is renewable or non-renewable. But you know that when you will fossil fuel you will use, and you will not get back within your lifetime. Okay, so that is why. So this subject is very much essential for the worldwide, specifically the developed countries, and those. So those are trying to so convert this from uh, non-renewable to the renewable. So, so people are going to discuss the renewable energy. We'll think about what is energy. So you did study in your school levels, but we'll think in a, here in a different way, in a nutshell. So you know that energy is the capacity of system to perform work, and it exists in several forms such as kinetic energy, potential energy, chemical, light, electrical, and sound, whatever. So we are having the different source of energy, and you know that according to the law of conservation of energy, total energy of a system remains constant. So only it will transform one form to another. So our intention to convert one form to another. So it may be in the form of chemical energy. Say for the fossil fuels, we'll convert it into the initial into the mechanical energy, then we'll convert into the electricity. So ultimate intention to convert into the electricity in a different conversion mechanism. Okay, and massive energy is an essential input parameter of socio-economic development of any system or society. Or it is used as a measure of living standard, quality of life, civilization, and culture of the society. You know that. So today we'll say developed country, developing countries. So India, you know that it is a developing country. China is also like developing countries. It's Pakistan, Bangladesh. But when you say about the USA or UK, UK is a developed country. So that means so their living standard, living quality, civilization, and that is based on the energy utilization, energy consumption. So these are the factors, matters for a society. Okay, so energy consumption is a vital parameter. Okay, so that is very crucial. So that is very essential. Not only that, if you look into the Indian context, now government or as well as state government as well as the central government, they are giving the thrust for the generation. You know, not only that, now The government of India is trying to supply the power to their neighbors, say Sri Lanka, Bangladesh, as well as Burma. And not only that, so people are thinking about the global grid. So now we have the national grid. So we'll supply to the power to the other state or other countries also. So these are the things is coming. So energy is basically a vital parameter for your development. Oh, okay. So if you think about the last, say, 10 years back, so 60% of the rural village don't have the power. Now, so based on the submission of this 2012, so power for all. So now, so government is trying to provide the power to the all villages, all the households. But till date, some of the locations we are not able to provide the power. So due to the remote location or distance from the grid, so there will be some of the other issues. But it is a prime intention to provide electricity to all the households of the country. So there is a term I will show, that is a per capita consumption. So that is a and measures, and it defines it is a yearly use of goods and services by each person by the total population, and that unit may be divided by the basically the dividing the quantity of goods and services used by the total population. So we are having a population using, so that will be used by the is person divided by the total population. So that basically parameter will be not only so based on the utilization, but also it will depend upon the population. Okay, so this variable serves as a direct measure of personal economic well-being of the country or the society. So this is the living standard that will give you the living standard. So how, if you look at here, I will show some just figure. So based on the figure, so this is the per capita electricity consumption of the different countries. So think about the colors. So here, if you think about the colors like blue, violet, so these are basically over the 2000 watts. But if you come to red, so think about the only 0 to. So blue and violet, these are basically located here. So this is basically the USA, Canada. Okay, so basically they are consuming more. So not only that is basically, so due to the location, basically they are the cold countries, they need more power to survive. But if you look into the red areas, African countries, South America, as well as India, Bangladesh, Pakistan. Okay, so that will give you some indication about the consumption pattern. Okay, so that will vary with the location also. If you look into this range that you are having the mostly red. Okay, so that will give you some idea about the consumption of electricity, the per capita consumption. So consumption pattern will vary. Here you will get some figure. So basically this figure is large. Basically, I don't know, you have a number of zeros here. So these are in, so these are the large number, not, okay. So if you consider China as most population, that is 140 crore, and we are having 135. Okay, so don't worry, within the 10 years we will be the top of the list, I think so. Okay, so based on this the table, we will get some idea about the consumption. But think about the per capita consumption of average power per capita. Here that is nearly 100. But think about the USA. So this is 13 times more. China, this is 5 times more. On the other countries like the Canada is the highest one. Okay, so that so based on this understanding, they are consuming more. Okay, so based on that, you can think there is a UK, so there is a UK, Germany, there is South Korea. Okay, so that is a only a brief idea about the consumption pattern. So consumption pattern will vary or may vary with the. So now come to the main area of our discussion, that is renewable and non-renewable. What is renewable? So that term is very much catchy, and why this is so. These are renewable and non-renewable. So renewable those are basically, and that can be replaced by nature at a rate close to the rate at which they are used. Okay, so that is replaced. That is so that will be renewed basically. So that can be replaced or renewed by the nature at a rate close to the rate at which they are used. Or on the other way, you can say resources that can be replaced within a human lifetimes. So there is a duration within the lifetime if you can replace those resources, and those are renewables. So I think you have understood the term renewable. So we will talk about this. So those resources, so those will be replaced by the nature at a rate of close to the rate at which they are used. Say wind, solar, always you will get it. And not only that, you have the infinite source of energy. Says the sunlight from the sun or heat from the sun. So there is hardly matters the infinite source of energy. Okay, understood? Okay. So now I will ask in a intermediate manner. Basically, there may be a disconnectivity of the network. Na? So that is why I will ask. I can only visualize the screen here. Okay. So this is a typical situations we are facing. But non-renewable, so renewed very slowly or not at all. Slowly means it will take say million years or years and years or 100 years or 1,000 years, whatever the things. But at some of the cases, you cannot renew it at all. And resources that cannot be replaced once they are used. So those are non-renewable. So with this understanding, I will show the different type of resources. So those are renewable as well as non-renewable in a different cartoon or different figures. So today I will give the introductory lectures. I will show the different type of energy resources only. So this figure will show the energy resources, renewable and non-renewable. So lower portion you will get. So this is chemical, muscular. So basically, if you think in the earlier days, we have the. So this is a nuclear. Muscular nuclear means that is basically oxidization. Basically, if you think about the muscle power or something like that. So those are basically based on. I don't know how it is nuclear. So this I have taken from the different resources. So and geothermal. So we know we if you consider the heat energy of our interior Earth, we are having a large amount of heat in the form of magma or in the form of the hot rock, and that heat energy can be utilized in a different manner. We will discuss. So fusion, that is basically the fusion of hydrogen. If you think about the hydrogen energy, so fusion of hydrogen will be a huge energy. So nuclear. So these are the basically the so nuclear fission and fusion may be there. and gravity. So we'll think about the up and down motion of the what water of the ocean, and we'll talk about the solar. So these are basically indirect solar. So this is basically the biomass, so wind, and you know that wind is basically the manifestation of the solar energy, and due to the uneven heating of the Earth's surfaces. And now mostly we know that is the direct solar combustion devices, that is the solar photovoltaic cell. This is widely used nowadays. So those are renewable. But if you think about the non-renewable, so these are fossil fuels. You know that these may be coal, oil, natural gas, or nuclear. So there is uranium, thorium, plutonium. What are the different nuclear fuels we have? So those are fossil fuels. So as a whole, you can understand this is a category, but these are the basically the figure I'll show. There is non-renewable oil, coal, natural gas, say nuclear power. Those are non-renewable. But similarly, if you think about the renewable, we have the biofuels. You know that so people are trying to have the fuels like ethanol, biodiesel. You know that will take, and a lot of country has given a lot of emphasis to have the liquid fuel like the biodiesel or ethanol, and that will be replaced the conventional diesel as well as petrol. So that is, and some of the countries they are given mandate say 10% will be replaced by these biofuels. So, so geothermals, and that is basically the energy, the wind and hydro. You know that hydro is the clean energy, and you know that and that is also the renewables, and you know that that is mostly will get replaced by the hydrologic cycle. So there will be evaporation, transpirations, and that will be precipitations. So there is a always there is a cyclic process, and you will get the rain so during the monsoon, or you will get, and you can store the water in using the dam in a stream or the river. So that is clean energy as well as renewable energy. And solar. So, and in the solar, you will get the two type of energy. You can get the direct solar thermal, or you can get solar photovoltaic. So we discuss the two type of resources. So same thing here in a different manner. So non-renewable, renewable, and secondary. And that is secondary means we will convert the energy, or we will store the energy in the form of hydrogen. So you know that in a long run, people will say this hydrogen will be the ultimate source of energy. Basically, people will store the energy in the form of hydrogen. So that hydrogen may be generated from the different way. This may be due to using the electrolysis or using from different biofuels. So we'll discuss. Just a second, someone is knocking. So go to Devnath. Okay, so hydrogen means secondary means we will when you have an abundant electricity generation, in that you can utilize this electricity to produce the hydrogen, and you can store. And not only the hydrogen can be utilized in a device like the fuel cell or so direct convert. And some of the cases people are trying to develop the hydrogen in engine also, but some of the problems are also with the, and there is a storage and handling of hydrogen is difficult. So we'll discuss. So here you will get some idea about this. So this figure I try to show with most of the cases, that is it's a utilization pattern of energy resources within a short span, say only for the 500 years. So basically, the development, what are the development we see nowadays? So that development is not in a long run. It is hardly for the 100 years or 200 years. And within short span, we have seen a lot of changes in development. Yes, and that may be in the electronics, computer science, whatever the development we see, these are only hardly 50 years. So think about the 15th century. So people mostly dependent on what type of energy resources? Only animal and biomass. You know that most of the world that is horses and animals and people. Okay, and people take the heat from the biomass only. So there is no question of any type of fossil fuels. So this hardly I had a 500 years back. Okay, but so then the thing about there is a huge gap. So this is the 15th century and this is the 19th, mid 19th century. So only we have started digging some of the fossil fuels. So these are basically near the earth surface. These are this coal. So this is hardly about the 200 years history. So we have started utilization of the coal only. Then early the 20th century, we have started utilizing the oil only. Okay. So then let the 20th century, so there is a huge utilization of coal only. But if you think about the other, so so those are getting squeezed. So basically, when you will get a in the form of oil, you have energy density is very high compared to the biomass. Okay, and we have stopped to utilize those animal power. Okay, but and the subsequent, and if you think of this as coal, no? But if you have the oil, so this is see the oil, but when you have started to utilize more oil, and in that case there is a so there will be total basically. So this is the percentage sharing. Now within the subsequent the development of this oil industry, you also started to generate some of the natural gases, and and all of this is a byproduct of the chemical industry. So people are trying to utilize those natural gases. Now you know that we utilize the CNG for the buses, autos. Okay, and not only that in a furnace or other and and in a power plant also. And have started with the technological development. We have started to generate power from the nuclear. So now think about this mid of this century, 21st century, what we have. Yes. So think about this. So there is basically it will start with this hydrogen. Okay, so there will be some biomass will be there, and not only that, we'll talk about this some of the renewable. So now with this understanding, so there is a changes. So rapid changes of this energy consumption pattern with the time. So now we mostly concentrate on this basically renewable. If you think about the now our target by this 2030, so at least 30% or 40% will be replaced by this renewable. And if you know, and if you think about the other countries like the UK, and they have stopped generating power from the conventional power plants like the coal-based power plant. They have stopped now, so they have only the 2% or 3% power plants are there for coal-based power plant. Okay, but still, that in India is mostly dependent on the coal-based power plant. More than 50 to 60% power we are generating from the coal. We have the NTPC, we have the state electricity boards, we have the Reliance Power, we have the CAC. So those are generating power from the fossil fuels from the coal. So this is the main concern. We are consuming or we are utilizing a lot of coal, and we are generating a lot of greenhouse gas. We are polluting our environment, but we need to save our planet. Okay, so this is a a figure that will give some thought. So what we are now. Okay, so and within 50 years or back, or so next 50 years or 100 years, so there will be a separate scenario will come into the picture, because we are consuming the huge power nowadays. And not only that, some of the, and we have given the authority to some of the private companies, and those are utilizing their natural resources in a alarming rate. So that is the main concern. So we should think. So this figure also gives you some indication about the pattern. So what I have told. So in the earlier days, we are mostly dependent on the, so this is a percentage pattern. We have wood, then coal, solids. So think about the liquids pattern, it will come. And we are basically in a golden era. If you have things, we are here, we have all the cases. Gas. Okay, so this is basically the where we have the, so liquid fuels, basically the fossil fuels, you will not get it within say after the 100 years. Okay, so mostly it will go to the, based on the pattern, that is basically gas, hydrogen. So we'll think about the fuel. So liquid fuel maybe, so there will be a slight or little amount of liquid fuel you will get in the form of say ethanol or methanol or biodiesel, but it will mostly shifted with the gaseous fuels, hydrogen, or it may be methane, biogas. Okay, so that will be the projection. So now challenges, basically. Challenges means you need to have the energy supply, energy demand, and environment. So these things are three things are very crucial. So providing supply to sustain growth and requirements. So that you have to match with the requirements, basically. So that is the industrial requirement, the economic growth, a lot of things. And modern society depends on the stable and continuous flow of energy. So we need power for the 24 hours. So that is the thing. So now you know that we have, if you think about the Indian economy, so there is a huge, that is the IT sectors, and they are doing job for the 24 hours. That outsourcing. So that is not a time dependent. So this is not only for this 9 to 6, it is for the hours. Basically, we are catering the entire world. So this energy demands maybe, and that may generate more efficient devices. Basically, so demand will also vary with the devices, say transportation devices. So think about the earlier vehicles, but now vehicles. So this conversion efficiencies, technologies, industrial process, and efficient appliances. Basically, if you think about the household, we have lot of appliances, microwave, fridge, TV. So basically, so those devices should be more efficient, and you know that. So there will be some star rating, say 3 star, 4 star, 5 star. So that is basically should be more efficient devices for less energy consumption. And finally, you need to think about the environmental concern. So you need to save your environment with the less emission in the form of CO2 or NOx, SOx. And finally, if you think about the energy transition, that we will talk about the transition from solid to gases. So there is a mistake with the gas, that the gases. So gases means we'll talk about the hydrogen, methane. So When you have a gaseous fuel, so those will give you the clean burning. So formation of the pollutants are less for the gases. So these are the challenges are there in the all the topics we will discuss about the conversion technologies. We'll talk about the challenges. We'll talk about the environmental impact for all the energy resources. So this figure will show you for all the renewable energy resources. Biomass. We'll to discuss about the gasifier. We'll discuss about the digester. We'll discuss about the direct conversion devices. We'll discuss about the geothermal energy, sun. We'll talk about the solar collectors. We'll talk about the solar photovoltaic cell. We'll talk about the wind energy, wind turbines, so different type of wind turbines, its different components. Okay, and and we'll talk about the hydropower. So those are from the power engineering. I think they have studied a little bit about the different type of turbines, but most of the students from the different backgrounds, say electronics, civil engineering, computer science, IT. So I'll talk about the what is hydropower. So I think just a second. Kartik Shorkar. Okay. But please try to join within the 5 minutes. Huh? It is
স্যার
very
অ্যাকচুয়ালি
difficult.
মেলটা আগে থেকে পাইনি তো, ওই জন্য স্যার। আর ফোনটাও চার্জে ছিল।
ঠিক আছে ঠিক আছে ওকে
Can I write the roll number in the chat box, sir? The attendance is done.
লিখবে লেখো
Yes, sir.
so
Thank
write
you, sir.
your okay write your name okay let so discuss about what is wind energy we will talk about all the energy resources so here we will talk about the kinetic energy of the wind. So you know that so this wind you will get so due to the uneven heating of the earth's surfaces. So and there are a lot of type of so wind you will get. So this may be the local winds or global winds, but we are mostly interested about the kinetic energy. So we convert this high velocity or kinetic energy of wind into a mechanical energy with the help of a device, and that is known as the turbine, wind turbine. So there are the different type of turbines are available, and I think you might be seen in the coastal areas. Say, if you visit some of the areas like the Kerala or Tamil Nadu, you will get a lot of wind turbines are there in the coastal areas. And nowadays, India is the fourth largest generation in the wind energy in the world. And day by day, we are planning more, and we will cater all the coastal areas to have the wind farms. And that is a clean energy, so we will get directly. But some of the problems are there. So you will not get the power for the 24 hours. So you know that wind velocity is basically intermittent in nature. You will not get the power for the 24 hours. And so this is site specifics, and that means no wind, no electricity. So that is the main concern. And think about the solar energy. So this is you will and you know that sun is the ultimate source of energy, and you will get the sunlight, and we can utilize this heat energy, and that is obtained from the direct from the sun during the daytime, and that heat energy may be converted into the electricity using the different technique. Okay, so there may be different type of solar collectors, and finally we'll take the heat and we'll run some of the cycles. You know that uh, Rankine cycle and some of the organic cyclic processes there basically we'll discuss to convert into the mechanical energy and then finally electricity. But you mostly know about the solar photovoltaic cell, and now you will see most of the buildings, government buildings, and school buildings. On the top of the roof, you will get solar cells. Okay, so in our mechanical building, also we have a 500 kilowatt power plants based on these solar photovoltaic cells. So the government has given some subsidy, 50% subsidies providing, and we have an agency that is called WB. So they are doing their job to install most of the official buildings are to for power plants to provide power, and that is grid connected. So that power will go to the grid, and that is yes, okay. And some of the people are trying to put their plants in their building groups for the shopping malls or high-rise buildings. So basically, nowadays, cost of the solar cell are getting lower, and these are comparable with the conventional power. In the earlier days, the per unit cost was say 20 to 30 rupees, but nowadays it is coming down to 2 to 3 rupees. So so that so that is why most of the concentration nowadays goes to the solar photovoltaic cells. So not only that, nowadays a lot of recent development has been made to build the solar cell using say liquid solar cell or polymer solar cell. So those are very useful nowadays. Okay, so we'll discuss. And these are the different solar energy applications you will find. So heating and cooling of the residential building. Just a second. Shantanu Shui. Okay. So solar water heating, solar drying process. So solar drying means solar drying of the foodstuffs or some of the animal products. Salt production using evaporation, so the desalination process, and some of the solar cookers, solar engines for water pumping, solar refrigeration, solar electric power generation. So we'll discuss all the techniques when you will study the solar energy, but you will get a lot of devices. So those will directly use the solar energy. So this is the a cartoon for the geothermal energy. You know that in our interior Earth, in the Mother Earth, we are having a lot of heat source, and if you and that is a huge and and some of the location within the 2 and 3 kilometers, you will get a lot of heats, and those fields or those sites may be utilized for the power generation cell. So this is a particular location where you have some hot rock or heated rock. So you know that so there will be a lot of fields where having the volcanic activities are there. So those are basically nuclear activities. So here you will do some fragmentation or nuclear explosion, and you will feed the cold water through this line. Then what will happen? So this location will be utilized as like a boiler. So so with this hot rock or heated rock, you can convert this cold water into in the form of hot water or in the form of steam, and that will come up with this pipe, to the turbine, and that turbine may be designed based on this hot water or hot vapor. And when you have the turbine, so that will convert into the mechanical energy and you'll connect with the generator, you will get the electricity. And then you will also fed back to this cold water. So this is a cyclic process and you will generate electricity. So we have a lot of scheme, a lot of types of different types of geothermal resources and its utilization or its conversion in a different way to have electricity. So we'll discuss. So this is basically the pattern. If you think about the temperature of our Mother Earth is very very high. So this is near to this the temperature of the sun. So this is very high. We can't go beyond a certain limit. So we can hardly think about the say so 1 kilometer or 2 kilometer depth. Okay, so that is why. So this is completely site specific. You will get, that some of the location you will get a hot spring. Okay, so those are the particular field. So some of the locations in the art we have. So those are favorable for this geothermal energy conversion technology. So we'll discuss. So this figure will show you the how this hydropower will be utilized for the generation of electricity. So most of the cases, I think you have visited some of the locations where you have the hydro, that is a dam. So if you go to the this that is Maithon Panchayat, so in our state and some of the other countries in India, we have a lot of dams and we have the plenty of these hydro resources. We have a lot of potential. So here basically we will harness this hydropower from the running water using a dam. We'll store the in a reservoir and that will be initially in the form of potential energy. Then when you will pass through this pipe or penstock, it will be converted into the kinetic energy. Then it will, so this kinetic energy will be utilized in a turbine to generate to have the mechanical energy, and we'll connect this mechanical and we'll connect so this turbine with the generator to generate electricity. So that is the main intention. Basically, as a whole, in most of the cases, our intention to rotate a shaft, rotate a shaft, and that shaft will be connected with the generator. So that may be for the water, and that may be for the wind. Okay, so that is the main intention. Okay, so most of the cases we will rotate a shaft. So this, but for the hydropower, you need a lot of capital investment to build this dam, and not only that, it takes a long duration to build, say 10 years time. So that is why most of the cases government will take part for this type of power plants. So private sectors will not show an interest for this type of power plants. So this is a layout or this is a block diagram you will understand. So basically this is, so this hydropower is also the manifestation of the solar energy. So you are getting the water cycle based on the solar energy. So there is the evaporation, then formation of this cloud, precipitation, whatever the flow of water. So those are basically created by the sun. So this is the sun, then evaporation, water, precipitation, rivers. Then we will form a reservoir using a dam, then turbine, electricity. So as a whole, this is a complete form of the renewable energy resources. And this is, and worldwide people are utilizing, say, and some of the countries in the world, say Morocco. So those, if you think the 100% energy they are getting from the hydropower. So that is 100%. Think about the 100% power they're getting from the hydro. Say for the Russia, 60% power they are getting from the hydro. Canada, but they are getting the water that is a cold water. So there's nothing. But not only the technology is very uh, not that much complicated. Not only you have the turbine and that is directly connected with the generator. So that is not only that you have you will you will that you will maintain your system at the normal ambient temperature. But from the other power plants, if you think of the steam power plants, you need to maintain the temperatures more than 600, 700, 800 furnace temperature is more than 1000 degrees Celsius. For the nuclear also, we are having a lot of difficulties to maintain these radioactive materials, not only temperature. We are having a lot of heat exchangers. So a lot of difficulties are there for the other devices. But for the hydro, wind, so these are very simple devices. Okay. But for the hydro, it needs long duration. But for the wind, it takes few months to install a power plant. So these are the things are there. We'll discuss in elaborate manner. So think about the biomass. So here biomass, basically there is a living organism. You will get the organic materials from the living organism, wood in the form of wood, like agriculture waste in the form of waste material from the living organism, poultry litters from the different animal farms. So those are the materials will be utilized to convert into the fuels, convert to direct conversion in the form of heat. So those are the biomass. And if you think of the biomass is also the renewable, so because you can renew it within a short period of time. So how? Suppose this is a biodiesel. You will get this plant oil, and finally it will be utilized in a car. It will generate CO2. Then what will happen? You will so this CO2 will take by the plants and it will be stored in the from a
So we have another class. So can we leave, sir?
we have another class now.
Yes, sir.
Okay, so we'll discuss in the next class and we'll continue with the others. Okay, thank you.
Thank you, sir.
So next day I will start with the 10:30. Huh? So Saturday class I will take from the 10:30 and for the Monday it is the 4:30. Huh? I think so. This time is 4:30. I I don't know. Just okay. Whatever the time I will send the mail by 1 or before the class or any I don't
Yes,
have
sir.
some problem.
Monday it starts from 4:30 to 5:30.
Okay, okay, okay. So I will share the PPT by next week. So to the cover with that.
Thank you, sir.
Okay, thank you. Okay, you can leave. I will, কৌশিক হ্যাঁ করে নেবো ঠিক আছে মাঝি তো এম এর জায়গায় আই করে নেবো ঠিক আছে জে আই হ্যাঁ এম এ জে আই হ্যাঁ ঠিক আছে এম এ জে আই তো ও, ঠিক আছে চলো কি আবার জয়েন করছে এখন নাকি
হ্যালো স্যার।
হুম বলো
স্যার একটু নীলাঞ্জন দাস নামটা আছে কিনা দেখে নেবেন না?
তুমি কি লিখেছো কি দেখো নিরঞ্জন দাস
হ্যাঁ স্যার, একবার দেখুন। লিখে তো ছি।
আচ্ছা আচ্ছা আচ্ছা
ওকে,
নিরঞ্জন
থ্যাংক ইউ স্যার।
ঠিক আছে বুঝতে পারছো তো ক্লাস নাকি
হ্যাঁ হ্যাঁ স্যার।
ঠিক আছে চলো, আমি জাস্ট